throughout every subject that we teach. Okay, and let me introduce myself. I am Vivek Sharma, and I graduated from IIT Kharagpur in computer science in 2021 with 9.26 CGPA. Okay, and I scored 192 rank in GATE examination 2019. Right. So the main reason behind the rank and the pointers is basically the fundamentals. Right. So we are starting with algorithm today, and I have written some very minimal topic here. We will go more into details and we will cover more subtopics, right? These are only the major topics that we are seeing. That's not it that we are going to cover in the syllabus. Syllabus, like in GATE examination, if you see, the syllabus is given like this only. Okay, this much syllabus is given, right? But that's not it actually. Once you go into the spanning trees, minimum spanning tree, you will see many algorithms related to minimum spanning tree. Similarly, once you dive into graph traversal, there are many algorithms, many ways to traverse the graph, and many ways we can find out so many things. Okay, so we will start with very basic things like what is algorithm. Okay, let's start with that. Okay, so a algorithm is nothing but sequence of steps that we do to solve a problem in computer science, right? Sequence of steps. In rough manner, we try to write some sequence of steps so that uh, the other people, research paper readers or computer science journals understand that what are these steps and what things do we need to execute these steps, right? For example, very simple example that I want a summation of two numbers. Okay, I want a plus b, and I want this result to be returned, right? So what is a? You will first figure out what is a, what is b, right? These are two variables. The mathematical variable, like in mathematics, we know we indicate x, y, such things, right? Similarly, first we will take input from user that what is the value of a? Is it 10, 20? User will input the value. So we will take input of given numbers a and b. Then we do the summation, store in some third variable c, and we return the variable. So these three steps are required to do the summation of two numbers. Okay, so this is a algorithm to sum the numbers. Okay, very simple algorithm. So before going forward, can you guys tell me your background so that I can go as per that? If you are very starting just with the computer science, I will teach as per that. If you have some basic knowledge of mathematics of computer science, so I will start with that base. Else I will consider that you are just 11th, 12th, like you are just graduating from high school, and I'll start from there. You can unmute yourself, right? Or you can type into chat.
Hi, sir.
Yes, who's this?
Yeah, I'm Devesh.
Yeah,
So
sure, Devesh. Go ahead.
I graduated from university in 2021 pass out from computer science.
That on a provided input, like a very generic input, very huge and large input. Uh, some programming language is performing very good, and another one is performing very poor. For example, if you provide given a language where you are providing an algorithm, okay, suppose that algorithm is algo 1, and you are running it on C program. C program. Generally, C program takes few, for example, if our algorithm is very small, it will take very few milliseconds. Okay, milliseconds. Generally, they take milliseconds or seconds. But if you execute the same algorithm in Python, it will take like 10 times more than this C programming. It will take around 10 milliseconds. If this one is taking 1 millisecond, it will take 10 milliseconds. This happens because of the compiler, but it is just 10 times. We don't consider 10 times to be very huge, right? Because once we provide very large input, this gap decreases. Right? So our algorithm should be programming independent. Generally, they are programming independent. What I'm trying to say here is C program, if C program is taking only 1 millisecond and Python is taking 10 milliseconds or even 100 milliseconds, they are not very, like, that is not very huge difference. We can consider them as a programming independent language because C programs are very raw. There's not much of the like heavy library behind C and C++ program. In Python and Java, we have virtual environments. In Python also, we have virtual environments where we have to do machine independent coding and such things which take that much time. And that is not the part of the course of GATE examination, right? So you are not going to learn languages in GATE examination. Java, you are not going to learn. You are going to learn, instead of Java or Python, you are going to learn object-oriented programming. Okay, object-oriented programming in your BTech. But I think this is also not the part of GATE examination. So that is why your focus should only be on C programming language. C programming language. You should know very basic fundamentals of C programming language. That we will cover once we go through the course: algorithm, data structure, and programming, right? So the property of algorithm is it should be language independent or programming language independent, and steps should be finite. Okay, and algorithm should generate some output also. These are very basic fundamentals, constraints. Okay, now let's move on to some more things with algorithm. Okay, so can you tell me that what is the time complexity for this program? I have written a very small snippet of program here where I am executing a for loop from I 0 to n. Okay, 0 to n, right? So what is the time complexity, or you can say time complexity analysis we are doing? So what is the time complexity for this for loop? You can unmute yourself and tell me, like, yeah, let me. Yeah, hi Raju, welcome to the class. Okay, one thing, let me make it very clear. This course is going to be very interactive because as you can go and check my recorded video, like sir can provide, but I don't want that. I want this course to be very interactive. Okay, so what I want is try to unmute as soon as possible when I try to interact you. Like I'm also around your age only, right? So we can communicate.
So the program will run n times.
Okay, n times. It will run
N times.
You are saying, be very careful when you say that the program runs n times. Okay, you said that program run n times. It's not the program. It's actually there are
Code.
few things. Yeah, which code, which line of code? Like this is line 1, line 2, and there are few parts in the line 1 also. Okay, if you are clear with this, you can get like one number questions very easily. Okay, so be very focused here. Whoever joined just now, please look for this course snippet. What I am trying to do here is I have given this 2 line of code. Okay, let me hide it. I have given this 2 line of code only, and we are doing time complexity analysis here. Time complexity analysis here. Okay, time complexity analysis. So what we are trying to do, we are trying to figure out which part of this code is running how many times. Okay, so Devesh is going to answer it. He's saying that the program is running n times. It's not the program. He's saying the code. It's not the code. This line is running n times. Sorry, n times. And Devesh, can you tell me like how many times this line will run? This code will run how many times? I less than n.
Yeah, it will also run n times.
Are you sure? Like, I think
No,
it
no,
will
it will run n plus 1 times because
yes,
it will check the condition the last time, which will be not be true.
yes, yes. So you have to be careful like this in the examination, and you will get one number, right? And you can get a minus like 0.25 also. But if you are careful here, and you will check that how the for loop is running. Let me use red color. Initially, once for the first time this line is executing, this will execute only once, only once. Okay, only once. Then it will check this condition. For the first time, I'm saying it will check this condition. It will execute this line. Okay. Then it will increase the value I. Again, it will check this condition. It will execute this line. So this is how it is going to happen. When this program is going to this for loop is going to end when the value of I become n. Okay, at the end of this for loop, the value of I will be n, not n minus 1. Remember this. Okay, so this is the order of execution. Initially, the value of I will be initialized to 0. Then we will check that, okay, I is less than n. We will execute this line, increase the value of I by 1. And we will again check the condition, again execute this line. So this line will be executed exactly n times when the value of I is 0, 1, 2, n minus 1 till n minus 1. When value of I is between this set, okay, when a value of I belongs to this set only, 0 to n minus 1, then only this line will execute. When value of I become n, this line won't execute. So if you count the values here, it's actually n. Okay. If you count the value of I, it's actually n. That is why this line is executing n times only. And this condition is executing one extra time, where this condition will fail. That is why actually the time complexity analysis says that n plus 1. But whenever we say time complexity, we never write exact number of steps. We do some kind of rough analysis, or you can say approximate analysis. So in case of approximate analysis, we say that it's order of n. You will understand what is this order in asymptotic notation. Soon we will cover asymptotic notations also. This order, theta, omega, these symbols you will understand once we go through asymptotic notation. But before this, I hope you understand how a for loop executes. Okay, so Bhumika just entered. This is very important concept. Bhumika just entered in the classroom. I'll go through it once again. But everyone else, can you tell me that you understand how this for loops executes? Just say yes or no. If you have any question
Yes,
before,
sir.
if you don't, yeah. If you don't understand this for loop execution, I cannot go further because there are many gate examination where they have done something very like a little bit of change here, and they have asked you the number of steps it's doing, or output of X or output of I after the for loop, and people generally do mistakes there and lose the marks. Okay, so Bhumika, what we did here is, let me try to go back as much as I can. What we did here is we have written a for loop, very simple for loop, and we did a analysis on this for loop, that how this for loop is getting executed. Okay, so Bhumika, you can unmute yourself. Only you will answer. How many times this for loop is executing actually, or I can say that this line, if I tag this line as 2, line number 2, how many times it's executing?
Times less than n.
Not less than n. Give me exact number.
1.
One time, only one time this line is executing. Okay, so do you know how
Okay,
for
wait,
loop
n
works
is 0,
actually?
right? Is n 0?
N is n. I'm not talking about, you can consider n to be very huge number. I'm asking in term of n, right? You can say n by 2, n minus 1, n plus 1, n number, like this. So we initialize I to 0 initially. We are checking that if I is less than n, suppose our n is, okay, if you not aware of, like in generic term, you cannot answer. You can assume that n is equal to 500. Now tell me how many times this line is executing.
Okay, I'm just gonna guess 499 times.
No, it will execute 500 times. Okay,
Okay.
don't guess it. Try to figure it out, like how it's going to happen. Let me again try to draw the flow. Initially, for the first time when we enter to this line, I will set to 0. Okay, we initialize I to 0, right? Then it will
Okay.
check this condition. Then it will check this condition. You can run for n equal to 4. In your mind or in your notebook, you can run n equal to 4, right? Then it will check this condition. This is the execution, right? This is the first step.
Yeah.
Let me remove the line numbers. It may confuse you. First, this step will execute for the first time only.
Okay.
Then this step will execute. Then this step will execute. Then this step will execute. Okay. Then again this step will execute. So it will go in loop like this. After this step, this line will execute. If this step satisfies, it will enter in this for loop. Then it will go to I++.
Okay.
Then it will go back and check the condition. So this condition is satisfied for I equal to 0, I equal to 1, I equal to 2, I equal to 3. N is 4, right? N is 4. So this condition is satisfied
Okay.
for I equal to 0, 1, 2, 3. So how many times is executing? 4 times,
4 times.
which is equal to n, right? So this line will
Yeah.
execute n times, right? But when I become 4, by executing this line, I will become 4. Okay, and this condition will fail. So this second step, or you can say this highlighted step will execute actually how many times? 5 times. So for the last time, this condition will fail. That is why it
And
will
then it
execute
is.
one extra time. So it will execute one extra time. Okay. Okay. Let's
Okay.
move on to the next. Let's move on to the next question. Bhumika, you can mute yourself.
Yeah.
Now let's go to the next question. Here again, you guys can give me your answer. Is there any chat box here? Let me check. Yeah. You can post your answer for this one very quickly. Like how many times this line is executing? How many times this line is executing? Don't copy paste your like each other answer. Very quickly post the answer in chat. How many times this line executing?
Sir,
Like
n times.
yeah, don't tell me in, like post it in chat.
Okay.
Okay, I will tell you to
Sorry.
when. Yeah, it's okay. Yeah. Correct. So this line will execute n times, right? Why? Because how many times this condition will get satisfied? It will get satisfied n times. 1, 2, 3 till n. Because we are checking when I is less than and equal to n also, right? Equal to n. So this will execute n times. We can say that it's order of n. The time complexity is order of n. Order means worst case. Order of n means worst case, you can say, or you can say upper bound. It cannot take more than this. Okay. Now let's go back to the second problem where we are saying that we have two for loops, one inside another. So this is called nested for loops. Now tell me the time complexity for this one, Devesh, Bhumika. You can try and tell me the time
Sir,
complexity for this one.
should I put it in chat or I can tell it?
No, wait for it. Whoever is like not confident on it can ask me. We are going to discuss this for loop and some alternation of this one also, right? Okay, let's do one thing. Let me give you a way to solve it. A way to solve it is initially the p will be 1, right? So p equal to 1. So for p equal to 1, if value of n is very huge, consider the value of n to be very huge, okay? Right? Each time whenever you say some generic terms of n and value of n is not given, consider the value of n to be very huge, okay? Like in billions. So when p value is 1, how many times this loop executes? This loop, the inside loop executes. It executes because you have answered the this for loop, right? That is why I'm considering that you can answer this for this loop also, this for loop also, right? So when p equal to 1, the inside for loop is executing for, I am talking about this line, okay? The inside for loop is executing for n times, right? When p equal to 2, the inside for loop will again execute for n times. Why? Because when p will set to 2 after this p plus plus, this k will again set to 1. Okay, that is why this inside for loop will execute n times. When p equal to 3, it will execute n times, and we'll go back till p equal to n. It will execute n times. Now when p will become n plus 1, we will go outside this for loop. We'll get exited from this for loop, and we cannot execute the inside for loop again. So how many times is it? How many times is it? Like for p equal to 1, we are executing n times. This for loop, the inside for loops, we are executing n times. For p equal to 2, we are executing this inside for loops n times. Similarly, till n, we are executing it n times. So it's basically n multiplied by n, right? So it's n square. I can go into more detail and tell you the execution order here. Just tell me if you don't understand why is it n square. Any one of you can ask me the question. Shubham is so late. Yeah, it's okay. Yeah, Shubham is the newest person here. So can you tell me, Shubham, what is the time complexity, or you can say, sorry, what is the time complexity for this this nested for loop? Or you can say how many times this line is executing, this a equal to b plus b.
So
How
can
many
you
times?
listen me?
Yeah, Shubham. Now.
Yeah. So time complexity will be k into n, and the number of time it will be executed is like k into n. Only k into n.
K into n.
Yeah, sir, k into n.
So how you come to this conclusion k into n?
Because for each iteration of the p, k will run till no, sorry, n square. Sorry,
Yes, right.
n square. I thought K and P are like the final one, N square.
Yeah, so let me again tell you. The variable which is actually running the outside loop is P. The variable which is running inside loop is K. Okay, so we are tracking these two variables, K and P. N is given to us. Assume N is to be very huge number. Okay, now in terms of N, how many times this line is executing? Right? So for P equal to 1, I've explained for P equal to 1, I have explained this loop execution. Okay, this loop execution using this example. That this will, or you can say these two are very similar example using this example, that for P equal to 1, the inside loop is running actually n times. Similarly, for P equal to 2, it will run n times. For P equal to 3, it will run n times. For P equal to n, it will run n times. So if you add these n times, okay, n plus, n plus, n plus, how many times? N times. This will turn out to be n square. Right? Any doubt here? Please stop me and ask questions, because we are like going as a building blocks. If you don't understand this one, we cannot go forward.
No doubt, sir.
Yeah. Anyone else? Chandana.
Clear.
Clear, sir.
Okay. I hope it is clear. You can ask me anything, right? Any silly question, because gate examination is very important. Even if you are here for any fundamentals learning, it is very important to learn algorithm. Okay, this is very basic thing for computer science. If you don't know algorithm, you cannot stay anywhere. Like, it will always drag you down. Anyway, let's move on to the next problem, where we are going to use while loop instead of for loop. Right? We are saying that, okay, we have initialized I to 1, and while I is less than equal to n, we will do I equal to I plus 1. So how many times this line will execute it? This line? N times, right? Whenever I ask something, you can try to write in chat. Okay, you can write it here. Yeah. So how many times this line is executing? N times. But when I do I equal to I plus 100, how many times this line is executing? Now this is an interesting question. You guys can tell me how many times this line is executing, or this whole while loop is executing. Tell me in terms of n, like n by 2, n by 4, something like this. Hello.
Yes.
So somebody answered n times. Raju have answered n times, and Shubham have answered 100 by n. P from P. Who is P?
Hello,
I address you as P. Yeah. What is your full name, P?
sir. Actually, it's Piyush. Actually, I couldn't write it.
Yeah, it's okay. You can change your name later on, tomorrow also. It's okay. Yeah.
I wrote it as
So,
n by 100.
yeah, that is correct actually. It is n by 100, not 100 by n. Why? You can consider an example as 1000 or 10,000. Okay, just to make it easier for you. Okay. So if you take I equal to 10,000, right? Or let's say 1000, not I. Let's make n equal to 1000. Initially I is 1, right? After first execution, the I will be 101. After the second execution, it will be 201, then 301, 401, 501, 601, 701, and 801, 901, and 1001. Once the value of I will become 1001, will be like this while loop will end, right? Because this condition will fail. I is less than equal to n. Value of n is 1000. So as you can see that we are increasing the value of I by 100, right? So the execution will be n by 100, number of executions. You can count it, right? 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10, right? Only 10 executions are here, right? So value of n was 1000 divided by 100 is 10, right? So very smartly Piyush, and there's one more guy who have answered it correctly. Why 1000 like 100 divided by 9? How did you come to this, Shubham? So actually Raju have also answered n. It's not n, it's n by 100. I think we have all got. Yeah, don't like mix up the concepts. So it's very easy, right? Now the variable that we are tracking right now here is I, right? Because each time we are comparing I with n. For this while loop, n is not changing. Only I is changing, right? I is increasing. The value of n is very large and I is increasing by 100. That is why we will execute only n by 100 steps. There is a very simple mathematical proof for it, but I'm not going into proof because I did it with an example where n is 1000, right? So similarly, if we change the value of I from I equal to 2 into I, instead of doing I plus 100, I am at each step I am doubling the value of I, or you can say I am multiplying the value of I, the current value of I, with 2. Now what will be the number of executions for this line? Number of executions I want. And this has been asked in GATE examination, that what is the time complexity for this program? What is the time complexity of this program? Right? Subham have answered something. Log n base 2. Okay. This is interesting. N by 2. Subham have changed its value to n by 2. Mani is saying n by 2. So Mani and Shubham, can you tell me one thing? What if I do here? I do while I less than equal to n. Initially, I initialize I to 1, and I do I equal to I plus 2. We have seen that when we did I equal to I plus 100, the time complexity was n by 100. Now, if I do I equal to I plus 2, it will be n by 2, right? So it cannot be n by 2, right? If I do I equal to 2 multiplied by I, it cannot be n by 2. What is that I'm asking? I'm asking number of times this steps is executed, that this condition is satisfied how many times? How many times this condition can be satisfied? Okay. So I will get with the first answer. Yes. Shubham, you can unmute yourself and try to explain. Like why is it log base 2 and
Okay,
why?
sir. So what happened in first iteration, i's value change into I by 2. Okay. Then in second iteration, it will be I by 4. So it will be keep continue going like I to the power 2 to the power let's say p. until unless it will be like greater than n. Okay, so sir, we generally need the value of p there, right?
Yes.
We need the value of p. That will only become if we take a log of n, log over n at a base of
It's
2.
not log over n. It's not log over n. So let me tell you, like Shubham, you can mute yourself. Very good.
Okay.
Right. Let me tell you what Shubham has explained. So I was planning to explain this thing to you. Right. Using some values, we can calculate number of times this step is executing. Okay. This step will execute as many as time this condition is satisfied. And what this condition says that, it says that I should be less than equal to n. It should always be less than equal to n, right? Now let's take the value of I initially. Initially we set it to 1. So initially I equal to 1, which we can write as 2 to the power 0. Initially it is 2 to the power 0. Okay. Now after first iteration, we multiply the value of I with 2. So it will become 2, which is 2 to the power 1. After first step, okay, this is first step. This is first step. After second step, we multiplied it again with 2, which is 4. Okay, so it's 2 raised to power 2. After third step, it will become 2 raised to power 3. 8 is 2 raised to power 3, right? After fourth step, it will become 16, 2 raised to power 4. It will keep on growing until its value, for some value k, for example, for kth step, I'm assuming there is a kth step. We don't know the value of k yet. Okay. It should be less than equal to n. Okay. Now this condition is not satisfied. This condition is not satisfied. At the kth step, the value will become greater than n. The value will become greater than n. Now let's take log both sides. Once you take log base 2, you will take log. Okay, let me use some other color. I'm mixing these up. Yes. So once we take log to base 2 both sides, okay, we are saying that our loop will break where the value of I will become 2 raised to power k, right? The loop will break here where it's exactly greater than n, right? Now once we take log base 2, 2 raised to power k both sides, it is greater than n. Okay, log base 2. We have taken log both sides, right? Log both sides. Now it will become, this will become k log 2, and everybody knows that log a is equal to 1 actually, right? So the k is greater than log 2n, right? So for worst case, it is equal to this one. Okay, greater than means we will consider the the worst upper value for the last step. We cannot say that it can be very greater than, like, very compared to n, compared to log base 2n, it cannot be very large. Okay, for the upper bound, it can be only log base 2n, right? So what I was asking is, how many times this step is executing? This step is executing k times. Kth step. At kth step, we break the loop, right? And we come to the conclusion that it is actually log base 2n. Log base 2n. Okay. Now tell me, like, this may be a little bit complicated for you because you have done logarithmic in your maybe last time in your 12th class. So if you don't know logarithm, go back and check the basic concepts of the logarithm. It's very important for algorithm. In asymptotic notations, mostly questions have been asked on the logarithm only. Okay, so you have to go back and check the logarithm, like the basic properties and basic operations of the logs. Now tell, like you guys can give me some feedback here. Like, did you guys understand this? Like, what is this kth step?
Yes, sir, we got it.
Like you have answered it already. So I'm asking everybody else.
So kth step, can explain me once, sir?
This kth step. Okay. Let's answer it again. So did you understand that how the value of I is increasing? It's increasing like this, right? 2 raised to power 0, 1, 2, 3, 2 raised to power 4.
Yeah, yes, sir.
Right?
That and yeah.
Yeah. So these many steps we have executed till now. For example, here we have executed it 4 times only. And within 4 times, the value of I becomes 16, right?
Yeah.
So if we assume that there is a kth step where this while loop breaks,
Mm.
and when will the while loop break? It will break when the value of I, 2 raised to power k, will become greater than n, right? Until
Correct,
it's
correct.
less than equal to n, it cannot break. While loop can break only when we assume
It's
that there
greater
is a
than.
kth step at which at that step the while loop will break. And for each step, you can see at the 4th step, the value of I was 2 raised to power 4. At the 3rd step, the value of I was 2 raised to power 3. So at the kth step, what can be the value of I? 2 raised to power k, right? And we are saying that at this step, assume that at this step, the while loop breaks. So it should be greater than n, then only while loop can break.
Correct, sir.
Okay. Now take log both sides, log base 2. Okay. Log base 2, take log base 2 both sides. Now you know that the property here is, once I say log a to the power b, it is actually b log a. The power can come forward, right? You know this property, right?
Yes, sir.
Yeah, that is why I can write this one as k log base 2 rather than log 2n, right? Now this log base 2 is 1 actually, the value of log base 2. I already explained that log base a and a is actually 1. This is the logarithmic property, mathematical property, right?
Yeah, yes.
So the k will become log base 2n. The value of k is log base 2n. And what was the k? What is k actually? Can you tell me what is k?
Number of
What is
steps.
the meaning of k? Yeah, number of steps. And that is what we are looking for. The number of
Correct.
times this while loop execute, that is what we are looking for.
Yeah.
Okay. So I
Yes, sir.
hope now you can connect it like, okay, at the kth step, we have gone outside of the while loop. And what is the value of k? It's log base 2n. Using this
Yeah.
reduction, we can say that it's log base 2n. Okay.
Yes, sir. Mm.
So we are good, I guess, right? So the time complexity, or you can say
And
the complexity analysis that we did, the number of steps, number of times this step is executing is log base 2n. Okay. Right. So now try to understand this. Whenever we do some summation, it is basically n by 100. This summation, like whichever value we did here, with that value we have to divide the value of n. We have seen that, right? So I'm concluding it that while value of I can be initialized as 1 or something else with any value, I is less than equal to n, and we did this step, I equal to I plus 20, we did, right? So whichever value I am adding here, the gate may give you some constant value here. They can say that instead of 20, I'm writing some value C here, right? So what is the number of steps, number of times this line is executing? It's n by C, right? 100 was just a constant, just a, like an example, right? So if I write C here, you can simply say that this step is executing n plus C, n by C times, right? Now instead of n by I plus C, I did like I multiply by 2, and using this derivation, we have seen that it's actually log base 2 n times this step is executing, and this is the time complexity. Time complexity can be denoted as this order of log base 2. This is upper bound. I will explain what is upper bound actually. This cannot take more than this roughly this much time, right? So what if I did I multiply by 5? So Shubham, don't answer. So who was asking right now? Money.
Yes, sir.
Yeah, Raju, can you answer that? What is the time complexity in this case? I multiply by 5.
Hello.
Yes, Money, you can answer that. If you have nickname, I can call you with the nickname also. So what is the time complexity in
Hamza.
this case? I equal to I multiply by 5. Yes, Raju is very accurate here. It log base 5
Log.
n.
Is
Okay, am I the only one who is hearing some disturbance from one side, or you can try to type in chat? We are not able to hear you actually.
you.
Yes,
Yes,
your
sir.
voice is breaking. It's okay. It's okay. You can try to type in chat because this recording may disturb them. Okay. So it's log base 2,
sir.
right? Because the value of this will increase with like 5 raised to power 0, then 5 raised to power 1, then 5 raised to power 2, 5 raised to power 3. We have to take it will become like this, right? 5 raised to power k for kth step less than equal to, sorry, greater than equal to n. We have to take log base 5 both sides. Okay. So the answer is log base 5n. Now let's move on to the similar question, which is basically we are given a very huge number n. Okay. And at each step, we are dividing n by 3. Okay. We are doing n equal to n by 3. Now, what is the time complexity? Or you can say number of times this step is executing. This while loop execute. Try to type your answer in chat. This is the similar question that we did here. I equal to I multiply by 2. This is very similar question. Okay, now you guys can tell me that if you understand this question. It's not 3n, it cannot be 3n, Chandra. So I did the derivation here. You can see that at the 0 step means before entering in this while loop, the value is n. Okay, the value was n before entering into the while loop, right? After that, what happened? We divided the value of n by 3. Then we divided the value of n by 3 again by 3. So n will become n upon n3 square. Okay, now n will become n upon n3 cube, right? So this is what's happening at the kth step, where the while loop will break. The n upon 3 raised to power k. Okay, obviously this is the third step, right? This is third step. At the third step, what was the value of n? It is n upon 3 raised to, compared to the first value. Compared to the first value, I'm saying, what was the value of n? N upon 3 raised to power n, 3 raised to power 3, sorry. So at the kth step, what could be the value of n? It is n upon 3 raised to power k. This n is the first n that we used before entering into the while loop, right? So this condition breaks the while loop. Now just simply try to solve it. Okay, so I did this thing, n upon 3 raised to power k less than 1, n is less than 3 raised to power k, and it's just the same thing. 3 raised to power k is greater than n. Take the log both sides, and we come to the conclusion that the value of k is actually log base 3n, log base 3n. Any doubt here? Because now we are entering into a little bit complicated question. Very small while loop. Okay, very good. Yeah. Chandana answered 3n. Now I hope she understands that whenever we divide the value of n, or we multiply the increasing variable, for example, in the previous while loop, we have taken a variable I here, right? And we increased its value because we are comparing I with n. Now we are comparing n with 1, and we are decreasing the value of n gradually, right? Gradually. So the graph will become like this, right? The graph will become, in case of I equal to like 2i, the graph will become like this, right? It will become like this. It's 1 here, then 2 here, then 4 here. Like this is exponentially increasing in graph, exponentially, right? So very quickly it reached to the value of n. Okay. Similarly, once we do n equal to n by 3, initially the value of n is here, right? For example, the n is here. Now, once we try to decrease the value n by 3, it suddenly come here. Then n by 3, it will suddenly come here. So it is exponentially decreasing value. That is why we are taking log 2n. So if value is decreasing exponentially, the number of steps are very less. Okay, if you know that whenever we try to solve the exponential, we always take log in the mathematics 11th, 12th. Whenever we have some a to the power x, we always take log a both side to calculate the value of x. We always take solve the questions like this. Now let's move to the next question, where instead of multiplying it with the some value, we are increasing the power of the variable. We are saying that, okay, initially I value is 2. Now I equal to I square. Okay. So I value 2 can be written for the 0th step. 0th step means before while loop. The I can be written like this, right? 2 raised to power 0. So 2 raised to power 0 will become 1. You know that the power 0 is actually 1, right? I hope you know that. Now it will become 2 raised to power 1, which is 2. So 2 can be written like this. 2 can be written like this. So once we square 2, it will become 4, and 4 can be written 2 raised to power 2 raised to power 2. It's not 2, it's actually 1, right? 2 raised to power 2 raised to power 1. Now once we square 4, it will become 2 raised to power 2 raised to power 2. Yeah, here it's 2. Once we square 16, it can be written like 2 raised to power 2 raised to power, I think it's 3 here. 3, yes. Right? Now at the kth step where this loop breaks, again I'm writing the same kind of concepts for you guys so that you don't miss this power concept also, right? Where we are, the comparing variable is squaring itself or increasing with a power 2, right? Now at the kth step, okay, this is third step, right? Third step. So at the kth step, it will become 2 raised to power 2 raised to power k, which should be basically greater than n. Now you take log both sides, log 2 raised to power 2 raised to power k, log 2 base 2, log base 2 n, and this will become, this 2 raised to power k will come here. This whole thing will become 1. So it will become 2 raised to power k greater than log base 2 n. Again, we have to take log base 2 both sides, right? So it will become log base 2 2 raised to power k greater than log base 2 n. Okay, and this thing is basically k. So k is basically equal to log n, where base is 2. It's log n. Now we have seen that in the previous example where we are multiplying or dividing, either dividing the value of n or multiplying the value of increasing variable I, then in that case our time complexity was log base 2n. Once we do the power, it's basically log n. So practice on these kind of questions. Always practice on these kind of questions. You will never lose the grip on divide, multiplication, or power. Right? Now there is a gate question here. This kind of question is being asked in gate. Yeah.
So,
Yes, Shubham.
so I didn't get that last question, sir. I square 1.
Okay. Which
Yes.
part you didn't get?
Sir, why it's like you got the equation 2 to the power 2 to the power k? It must be like 2 to the power and then 2 squared, then 2 to the power 6, right? It's 2k, right? Not 2 to the power k.
It's 2 to the power k actually.
Yes, sir. I think it's 2 to the power 2 to the power 2k, sir. Please try it. Explain it again, sir. Like 2 to the power 2 to the power k. How?
Okay, let's do one thing. Let me add one more slide here. Which page is it? This one, right? Oh, let me add one more slide. And I can clean this one. Yeah. So let's solve this again. The question was we are doing while initially I was 2, right? Initially I was 2 before loop. We are saying that I should be what? Once I is less than n, we are doing this thing less than equal to n, I equal to I square, right? Right? This is what we are doing. Now initially the value of I is basically 2, which can be written as 2 to the power 2 to the power 0. Is it okay, Shubham, till here? Before the for loop, before the while loop.
Yes, sir.
Yeah. Then we do 2 square, right? 2 square can be written as 2 to the power 2 to the power 1. At step 1, for the first time we are entering the while loop, the I will become 4. 4 can be written like this, right? It's okay with you, right?
Yes, sir.
Then it will become 16. 4 square is 16, right?
Yes, sir.
So it will become 2 to the power 2 as step 2.
Yes.
Right?
Yes.
Then it will become 256, right? 16 square is 256.
Yes.
Yeah. How can you write like how much is the power of 256? It's 10, 8, right? 8, right? 2 raised to power 8. 256 can be written 2 raised to power 8, right? So
Yes.
it's 2 to the power 2 to the power 3.
Okay, so I got it.
Got it? Now
Yes.
at the kth step, you can write it like 2 to the power k, where this loop breaks. It is greater than n. Now you have to take 2 times log both sides. If you take first log, it will become log base 2 to the power k greater than log base 2 n, right? Now once you solve this one, 2 raised to power come here, 2 raised to power k will become log base 2 n. Now once again take log base 2 both sides, so it will become 2 raised to power log base 2 raised to power k greater than log 2 n, right? And k will come here, so this k you can say it's greater than log base 2 n. I hope everyone got it. So using this we can solve the power, right? Anyone have any doubt, any problem here? You can stop me, ask me questions. We can move on to the next thing. Next question, similar gate question. Okay, so I hope it's clear. Now let's move on to this question, where we are doing I equal to I raised to power 20. We started with 2 and we are doing I raised to power 20. So what is the time complexity here? You can try to type in chat like before doing the derivation. I will do using the derivation, okay, like this derivation. But you should be able to do it without derivation. Once you see the power, see the initial value of n, you should be able to do it. Initial value of I. Okay, so let's type something in chat. I am waiting for your answer, then I will start the derivation. Okay, somebody has given yes. If you are not able to get it, you can simply write, okay, sir, explain it. I can explain. Okay, somebody have written, Shubham and Devesh have written log 20, log 2n. Yes, that's correct. So let me quickly write it. Initially, the value of I is 2, which can be written like 2 raised to power 20 raised to power 0. Okay, it will become 2 raised to power 1, which is 2 actually, right? Then after the first iteration, in the first step, after the first iteration of while loop, it will become 2 raised to power 20, which can be written as 2 raised to power 20 raised to power 1. Then it will become, and at the second step, it will become 2 raised to power 20 raised to power 2. At the third step, it will become I raised to I value will become 2 raised to power 20 raised to power 3. Okay, so similarly, we'll go to the kth step where it will become 2 raised to power 20 raised to power k, and which breaks the loop. So its value is greater than n, greater than equal to n, and we will take the equal to scenario for like upper bound, and we will take log 2 both sides, log 2. So first we have to take log 2. That is why log 2 comes the inner side. You have seen the answer, right? The answer is log 20 log 2n. In the gate examination, if this kind of question will ask to you, then this option will also be given, log base 2 log base 20n. Don't get confused. Whatever is the initial value will come inside, and whatever is the power will be the will be at the outside. Okay, so if you solve it, take log base 2, it will become 20 raised to power k greater than, or you can say equal to, log base 2n. Then you take log base 20, so k value will become log base 20 log base 2n. Okay, so these kind of question has been asked in GATE examination. Now, once you know this, you don't have to do the whole derivation. It will save your time. Whatever is the power will come outside as a base, and whatever is the initial value will come inside as a base. So we solved few GATE questions also along with the concepts. This is how we are going to go in the course. Okay, I'll give you one practice question here. Where is it? Okay, it's not here. So I'll clear the previous screen. The question is why n is greater than 2, n equal to root n. Okay, solve this one using derivations. Tell me the time complexity. Okay, it is homework, and this kind of question has been asked. You can take similar question also. N is greater than 2, sorry, is 2. N is greater than 2, and n equal to n upon 1 by 20. It's just the same question. Try to use the derivation so that you understand the derivation. Try to solve these two examples. We will discuss it tomorrow. Now I'm jumping on the next topic, which I have to finish today only. Then only we can move to the asymptotic notation. Okay. So if anybody is getting bored and is not understanding anything, can stop me. I can take your personal classes. Okay, without telling Dinesh sir, we can do this. Like, your GATE examination is very important step of your life. Are we clear here? Sir, your contact number. I need to ask Dinesh sir for that. For now, you can tell me here what is the problem that you are facing, and we can schedule, as per Dinesh sir, we can schedule a extra class for it. Okay, the main course will go along, and for these missed concept, you can schedule an extra class. Right. For the contact number, I have to ask Dinesh sir. I'm not sure. Okay, so Chandana, is there anything else that you didn't understand? Like, so there is a question on your screen. Okay, and we have seen that here we have three variables, I, J, and K. These are three variables. Today is my first class. I just want to know. It's first class for everybody. How much I missed? Yeah, Chandana, it's first class for everybody. We are just starting with this time complexity analysis, so that you should know like how to use asymptotic notation. It is very important. Once you know the time complexity analysis, then I can make you understand asymptotic notation. You don't have to mug up things there. If you understand, like, if code is given, you should know the time complexity analysis. So there are many GATE questions where you are given with the code snippet and you have to tell what is the worst case time complexity analysis in form of like asymptotic notations. So there is a program here. Try to solve it. Then I will try to explain like what's happening. Okay, so we will always start with the inner loop. These questions could be tricky also. Right? But that part we will solve in the next question, how they can be tricky. But for now, try to check it like this. Okay, this part, if single-handedly I run this part, only this code, how much time will it take? Try to type in the chat. How much time will it take? Only this part. So at each step, what we are doing, we are increasing the value of k by k raised to power 3. It's like I equal to I raised to power 3, right? But our target is not n here. Our target is not n here. Our target is n raised to power 5 here. Okay, n raised to power 5. And the initial value of k is 2. The initial value of k is what? It's 2. Log 3, log 2, n. Yeah, it's actually correct. In terms of asymptotic notation, if you write it like order of log 3, log 2, n, but it's not correct in terms of number of steps. In terms of number of steps, this n is actually n raised to power 5. It's not n, it's n raised to power 5. So it's actually log 3, log 2, n raised to power 5. These many steps we have to execute. Now, this n raised to power 5 can come here, right? You know that in logarithm, the constant power doesn't really matter. In logarithm, the constant power doesn't really matter. When we do time complexity analysis, try to write down in your notebooks that once we do log n raised to power 5, log n square, the log n raised to power 5 will become 5 log n square will become 2 log n. In time complexity analysis, these two are just the same thing. Constant doesn't really matter in logarithm. Okay, so both can be written like, both of these two can be written like order of log n, order of log n. This is also the part of asymptotic notation I will cover. Don't worry about it. But try to understand it here that this constant doesn't really matter. You know that 5n, 2n, 100n, all these is written like order of n here in asymptotic notations. N by 2, n by 100, this also will be written as order of n. Similarly, 5 log n will also be written as order of log n. Okay. So basically what I'm trying to say here is the number of steps that we are going to execute is log 3, log 2, n raised to power 5. Anybody didn't understand this thing? Yeah, Shubham is going fast forward. I only asked about the inner loop. So I will check Shubham's answer later. Before that, any one of you can tell me that if you didn't understand this inner loop, the innermost loop, how many times it's executing? It's like while initially k value is 2, we are doing while k is less than equal to n raised to power 5, and we are doing k equal to k raised to power 3, x equal to y plus z. This step is not contributing in the loop variables, so you can neglect it for now. But this is what we are doing in this for loop. Okay, so this is the initial value. This is the power that you are seeking. So using these two, what you can say that the initial value will come inside the inside log, and the power will come as outside log base, right? We have calculated this till now, right? And this is our goal that we want to achieve. This is our goal. So that is why it's n raised to power 5. Now this is for inner loop. What about the second loop? What about the second loop? Can any one of you tell me about the second loop, this loop? Here we are doing j equal to j by 200. Okay. So it's similar to like initially j equal to n. J equal to n initially. Then we say that, okay, while j is greater than equal to 1, and we are doing j equal to j divided by 200. So I hope you have seen the similar thing with n equal to n by 3, right? We have seen the similar derivation. So there the time complexity was log base 3 n. Here the j is actually equal to n initially, right? Equal to n initially. So it's log base 200 n, log base 200 n, right? So only for this loop, it's log base 200 n. What about the outside loop? It's order of n or n, you can say. Now you have to multiply all these things because this loop will run log base 200 n times, but again the outside loop is running n times, so it's n multiplied by log base 200 n multiplied by log 3 log 2 n raised to power 5. This is the right answer. Okay. So we are going from inside loops to the outside loop, and we have to multiply each loop time complexity. Okay. So it's log 3 log 2 n raised to power 5 here, log 200 n here, and n here. So it's n multiplied by n log 200 n log 3 log 2 n raised to power 5. Any doubt here? No, sir. Shubham? No, sir. Mani? So Raju? No, sir. Clear. Yeah, I hope it's clear. It's very important. This is the toughest question that could have been asked in GATE examination. If you clear with this concept, given any code snippet which doesn't include recursion, only include loop. After recursion, we will see the time complexity of recursion also. But till now, we have seen, given any code snippet where we have only for loops, while loops, you can solve any kind of time complexity. If you are not clear, you can stop me here, and we can go further. Now look at this question. What is the time complexity of this question? This is a GATE question. Previous one is not a GATE question. It's actually, I think, TIFR question, which is far tough compared to GATE. But still, I included this question, the previous question. Right. Now I'm talking about this question. Give me the time complexity for this question, please. Okay, so Chandana will answer. Chandana, you can unmute yourself and tell me what is the time complexity of this question and the way you are thinking for the time complexity. Okay, she's applying log everywhere. Why log has been applied? There is no need of log. Why did you apply log? You can unmute yourself, Chandra. I want to talk to you so that this concept is clear for you. When do we apply log? I can't unmute. Okay, it's okay. Yeah. CSE Varun have said, Shubham have said 0. 0 cannot be time complexity. Order of 1 can be 1. Yeah, Shubham have said 1. Devesh and raised to power 6. Yeah, Chandra, see, you can type in chat also that what do you think? Where did we apply log? Why did we apply log? So it's applied when the iterating variable, for example, this I or n, it has been divided, not I, n actually, for multiplication of iteration. Yes. So if you are like, for example, you say that if you do like 4, I equal to 1, I less than equal to n cube, I plus plus, right? So instead of I plus plus, if I did it like this, right? If I did it like I equal to I multiply by 2, then I'm trying to reach this n cube like exponentially. Exponentially means I'm trying to reach this n cube as soon as possible. Each time I'm multiplying the value of I, like it will 2, 4, 8, 16, 32. I'm skipping so many numbers. That is where we applied log base 2 here, right? Then it will be n cube. This is our goal. N cube is our goal, right? Don't try to miss it. Now, what you can do, you can go back and check the recordings very calmly, or you can take some extra classes. You can tell me. I will take some more simpler example so that you understand that why did we take log. Here, it's not the case. Here, it's I plus plus only. At each step, the value of I is increasing only by 1. So how can it be reaching n cube? So it have to do n raised to power 3 times. It have to execute n raised to power 3 times. Right? 1 second. 1 second. Give me 1 second. Okay. So here log cannot be applied. Here we are going to reach n cube like 1, 2, 3, 4, 5. We are not missing any single value. So if you going to reach to n cube, you have to take n cube steps. So here we are taking n cube steps. Here we are taking n square steps. Here we are taking n steps. And if you multiply all these 3, it will be n multiplied by n square multiplied by n cube, which is n raised to power 6. Power will be added in multiplication, right? So it will be n raised to power 6. But that is also incorrect. So everybody who answered n raised to power 6 is incorrect. 2 of them have answered 1. That is also incorrect. The actual answer is n cube. Let me tell you why. This question is asked in GATE. So this is a very a bit tricky question. If you miss the detail, your concept may not help you. The detail here is at each iteration, we are just using the same variable I. We are just using the same variable I. Now let me go and try to tell you what's going to happen here. Initially, the value of I is 1 here, right? Okay, it is less than n. Let's assume n value is very large, like very large number. Okay, it's less than n. Okay, let's enter inside the loop. Then we again set the value of I to 1. Okay, it's less than n square. Okay, let's enter inside the loop. Then we say that okay, I value is again equal to 1. Again we set the value to 1, which is less than n cube. Okay, execute this line, then do I plus plus and check again. So once this loop ends, what is the value of I? It's n cube plus 1. Once this loop will end, what is the value of I? N cube plus 1. Now remember the previous flow where I have explained single for loop. Okay, what will happen after this? Once this loop ends, it will go and increase the value of I. The value of I will increase to n cube plus 2 here, which is basically greater than n square. Okay, greater than n square. So it cannot go back here. It cannot enter in this for loop. Okay, now it will go back and increase the value of I plus plus again. It will be n cube plus 3, which is greater than n. So the time complexity is actually order of n cube. And if somebody asks you what is the value of I at the end of this for loop, which will be n cube plus 3. And if somebody asks you how many times this line is going to execute, it's n cube times. Okay, so focus on the detail also. Here we are using just the same variable I. We are not using ijk, pqr or some like 3 different variables. So the value of I at the end of this whole code snippet will be n cube plus 3. Okay, and this for loop will be executed only once. Every other for loop will be executed this for loop will be executed n cube times. This for loop will be executed only once. This will be executed only once. And as per the flow goes, these arrows, try to follow these arrows, right? Now everybody can unmute yourself and ask me questions, because I'm very serious about this question. This has been asked in the GATE examination. Okay, you should understand these kind of tricky questions also. This is the last question for today, right? In the next lecture, we are going to cover asymptotic notations. So unmute yourself and try to give me some feedback so that I can improve myself also. How the order is n cube? Yes, okay. Let's try to and go back to the. Can I go back? No, I cannot go back. So I have to erase it. Okay, let me try to write it in.
When you are going outside.
Wait. Just give me 1 minute. Okay. So it goes like, what is the question? Question is, for I equal to 1 initially, I less than equal to n, I plus plus. For I equal to 1 initially, I less than equal to n square, I plus plus. Okay, I think this is the question, right? I equal to 1 initially, I less than equal to n cube, I plus plus. And we are doing some x plus y z equal to some kind of operation here, right? This is the case. Okay. Okay, I'm explaining this again. Initially, the value of I will be set to 1. This is first step. It will execute only once for this for loop, only once. In the next iteration of this for loop, if that happens, this won't be executed. Then in the second step, this will check the condition. Suppose value of n is very high. we will enter in the next for loop. This step will be executed. The third step, it will check that okay, this condition will be satisfied. At the fourth step, it will enter in the inside for loop. It will be executed at the fifth step. At the sixth step, it will check the condition. Okay. Till here, what is the value of I? It is 1 only. Now, how many times this for loop will iterate? How many times this line will get executed? From I equal to 1 to n cube, right? These many times this will be executed. Once this line is executed last time, the value of I is actually n cube. Last time, value of I will be n cube once this condition is satisfied for the last time. Okay. Then it will increase the value to n cube plus 1. Okay. N cube plus 1. Once it increases to n cube plus 1, this condition fails. It will check the condition again. Again, this condition fails. Okay. If this condition is failed, then it will go back to the previous loop, this loop, and increase the value of I to n cube plus 2. Once the value of I is increased, it will check with the condition. It is less than equal to n square. No, n cube plus 2 is basically greater than n square. So this is not satisfied. It will go back here, increase the value of I. It will be n cube plus 3. And n cube plus 3 is greater than n. Right? It's greater than n. So this for loop will also be exited. But we will get outside of this for loop. Now at the end of this whole 3 for loop, what will be the value of I? N cube plus 3. How many times this executed? N cube times only. Rest is just the increments, right? One increment here, one increment here, one increment here, extra increments, and condition check. That is why I explained that thing, that how for loop executes. So I think Chandana joined late, so that is why I'll go back and clear this and explain one thing. For I equal to 1, I less than equal to some value, okay, for example n cube, I plus plus. How the executions happens? Some code here. I don't care which code. Another for loop, while loop, if condition, I don't care, right? I just write like how it will get executed. For this line will executed only for first, you can say first iteration. Okay. Then it will check this condition. If this condition satisfies, then it will go inside this and execute the code here. Then it will go back and execute this I++. Again, it will check the condition, execute the code, do I++, execute the check the condition, execute the code. This is how the for loop execution is done, right? And that's what we did here. I hope this explains the things. Now, if you have any doubt, you can ask me in the next lecture. Just tell me if you understand this one. Okay, so everybody was wrong for this example. It means that you have to again work on your focus. That focus, how many times this, what all the variables here, every single detail. Once you get the details, it's very easy to answer a very complex question in the GATE examination also. Sometimes you see this kind of tricky question. Actually, it's not very tricky, but if you have seen that, okay. So Shubham have seen this trick, I think. That is why he have answered 1, but he missed this for loop. Shubham have missed this for loop, I think. Shubham, you can unmute yourself and you can tell me your thinking, like what were you thinking? You answered differently.
To be honest, sir, I go with all of them, all the steps. And in n cube, I read correctly, like, yeah, it's n cube. I don't know why I wrote 1.
Okay, it's okay. I hope this is clear, and you can give me
Yes.
some feedback. Unmute yourself. Everybody can unmute yourself. One by one, you can give me your feedback. I will try to improve myself in that area and meet you in the next lecture.
So, sir, I enjoyed the lecture, and I'm really glad, sir, that you come with lots of the questions, and the questions were really good. So I didn't get time to get bored during your lecture, sir.
Yeah,
And
thank you, Shubham.
and sir, please just continue giving us a lot of the questions while teaching, sir, because it kills the boredom.
Yeah. It's not about the boredom. Actually, do we have a class tomorrow? I'm not sure, Chandra. You have to ask Dinesh sir for that. He gives me schedule. Today is just the demo class. So
Monday we don't have classes.
I'm not sure, yeah, Shubham, but Chandra is asking about the next class. So I'm not sure about that. Today is just a demo class. It's first class for me also and you guys also, right? So I was just recording lectures for you guys previously, and now I'm doing some interaction, which is good for me. Because recording lectures, I generally don't give questions like explain me this again, explain me that again, and if you didn't get anything, I can improve myself also so that you guys get better, best out of me. Okay. So tomorrow we will see in next lecture we will see some asymptotic notations. What you can do, you can head start with the asymptotic notation. It's a very simple concept. But if you don't know logarithm, asymptotic notation question will always have logarithm in it. Try to solve some logarithm like something like this, log base 3, log raised to power n, log power 2, and something like this. Or if somebody give you 1 upon log base n by n2. Okay, so this can be converted into log 2n. Some kind of these conversions, this simple logarithm, try to understand these simple logarithms, okay? See, logarithmic operations, divide and multiplication, summation, such things. Okay, thank you all for joining. I also enjoyed the lecture with you, and I am very happy that you guys are replying on chat or unmuting yourself. That's very good. Yeah. Thank you. Bye bye.